basically block diagram is composed of the many blocks and black box, and each black box can be a representative of certain the dynamics of subsystems. Okay. And if you have learned certain programming, this morning I just learned from my research assistant. He showed me how he programmed an app, Android smartphone, and basically he said this is a platform developed by MIT, and that's a graphical. You simply drag the box of certain functions into the platform, and you connect it in a good way. And by setting up certain inputs to each block, then combine together everything running well, then that will be the app. Okay, and he showed it right away, and that is funny. Okay, so basically the similar ideas, I think graphically, we build up the blocks. Okay, we're building the blocks, and each block can be a description of a subsystem of the entire system. As long as you know how to decompose the system you study, and there could be many ways. Okay, so we can use this one. And once we have a block diagram, then we can, based upon the certain simple rules, we can, based upon the block diagram, to derive the transfer functions. Transfer functions always is the first step we're going to achieve before we're doing the controller design. So this is the basic elements of a block diagram. So basically here is the input, and this is the output. So simply we define this is a single block, and in terms of this configuration, this block describing the relation between output and input. So this block is also the transfer functions. Okay, and so that is the basic element of the block diagram. For the block diagrams, connecting from block to block, we use the signal flow. Let me show it to you. So for the open loop system, and this is, let me use I as an input, and this is the block, let me call it G, and G is our transfer functions, and this is our output. Okay, so that is, right now we describe everything in the S domain, so that means you convert by Laplace transform, you convert all the time domain information into S domain. So this is the open loop system is the first one. So if we look at the closed loop system, and what's the difference? So this is our system, open loop system. This is our output, and say this is our input. Say for this control, for this open loop system, I don't like the response of the system. It's behaved so ugly, so poorly, and say there's a lot of these. For example, that could have a huge of the steady state error, or the output system have a very slow, very sluggy transient response. I wish the transient response can be quicker. I don't want to be slow. Okay, in this way you can impose the feedback system. So you feedback the output signal. So here in electrical circuit design, you simply put a wire connect to here and then feedback to here. Okay, and then you feedback to certain, say, op-amp, operational amplifier, or any other controller circuit. And in general, let me call it the CS. Okay. So all the apparatus or design or device put into the feedback loop, and I encapsulate into CS. And then here is the output of this one. I simply compare to the feedback system. So here I put into this one. So I compare my input to the feedback signal. Okay, so from here you can see this one I provided a summing point, and this term is not this term is, there's no unique names for that one, but people just know it. Okay, but in our textbook, the author call it the summing point. The summing point basically is this, just like I draw it here. That is to compare the two signals coming in, compare the two signals who inflow, and depends on the sign. So here is the outflow of a signal A minus B. So for this example here, this is our comparison. So we can define this is the error. Error simply is equal to I divided by, I minus C times O, and let me put it into function of S. So basically all the things is a function of S. Okay? Good. Okay, so basically this is one example of the summing point here. And depends on the design purposes, and most of the time when we have the feedback control, we put a minus here because we take out the error. We try to suppress the error as soon as possible, as good as possible. We try to suppress error to 0. Okay, so basically most of the time we try to interested in the error. But for certain rare control designs, people put a minus, put a positive here as well. Depends on your purpose. But I can tell you most of the situations we simply take out is the error. So here we take a minus. Okay, most of the time for feedback system is minus here. Okay. So this is the example of the block diagram, and compared to that example here, we this is called a unitary feedback system, which means we don't have any sensors. We directly take the output here. So basically E, for this case, E equal to how much? E equal to R minus this signal is C. Okay? So for this case, we can do it. So for that one, we can try. So from here you can see we can simply read the informations. And in terms of block diagram, C equal to G times E, right? Because in terms of these block diagrams, this is the input to the system, and that produces output. So we can do it here. So from here you can see carefully C equal to G times E. Okay, and then what is E? E per the summing at the summing point, that is R minus C, right? So therefore from here let me rearrange GR minus GC. So here we have two C's appeared on, so here let me rearrange. So I move this one, C 1 plus G equal to GR. So let me write it up here. So therefore C over R equal to G 1 plus G. C is our system response output, R is our demand, our command, our input. So therefore this is our transfer functions. Okay, transfer function G over 1 over G compared to the open loop. So for this one, C, let me say indices, and if this is R. So for this case, C over R simply equal to G. So that's the difference. Okay, so this process is we call the simplification of the block diagram. So for this closed loop system is equivalent to this system is this. So we have G 1 plus G, and this is C, this is R. So for that closed loop system is equivalent to this one. You good? Okay. So right now you know the rule. So maybe we can try the more complicated configurations of the block diagram. Then we see how can we simplify into the output to input. Okay. So for the block diagram sections, the remaining exercise is simply to do a little more complicated. So I think this should be C parentheses of S. So for this case, we see what happens. So this one is done by here, right? So if you have your lecture notes, we can do this one here. Okay, so that example is similar to this one. So for this one, let me stick with the symbols, and starting from starting from this block, okay, O equal to G times E. And then we drop off the function of S, O equal to G times E. Right? Okay, we simply look at this block diagram. So reading is O equal to G times E. And what is E? E equal to I minus C times O. Okay, so we can rearrange. So O equal to GI minus GCO. So here, let me move O to the one side, 1 plus GC equal to GI. So therefore, output divided by input will be equal to G1 plus GC. So this is our simplified block diagram. Okay, so for this case, that means this system will be equivalent to this 1 plus GC, and this is I, and this is O. Okay, so this system by itself will be equivalent to this one. Okay, so you can see the key point is we're starting from the output and we're using algebraic multiplications of the gain. If you remember our terminology, sometimes we call the system is called the system. Sometimes we call this as a gain. Chemical engineers sometimes like to call this as a plant, power plant, something like this. Okay. But anyhow, the key thing is we're starting from the output and do the algebraic multiplication of the system gain to whatever the input to that single block. And then from there, we trace back to the upstream, layer by layer, level by level. And that's it. There's no unique way because there's so many kinds of the configurations. We can look at the remaining example here. Okay, so for individual cases, so for the first case, simply is C equal to G2 multiply this signal in turn equal to G1 multiplied with RS. So for that one, we can put into this. So that means, if you like, I can write it out into the same order. So C equal to GQ multiply with whatever signal, that signal multiply with G1, G1 multiply with our input is R. Okay? Right now, my writing is to follow the sequence kind of drawing on the, but in reality, you suppose if you're familiar with it, then you can write it up like this. Okay? So basically, that system, if you like, you want to draw it, it's not necessary. But for the beginning, we can just draw it. So that system is equivalent to this. For the second system, if you look at this graph, so C equal to the summation of the two signals, and individually that will be equal to G1 times R or G2 times R. So from here, you can see we have a summing point at the output equal to the signal of summations. That is the summing point. So that is the G1 R and G2 R. So you can take it out, G1 plus G2 R. Okay, so therefore for this signal, for this block diagram, that is equivalent to G1, G2, and this is the C, this is R. Okay? For the third one, that should be very straightforward now, and that one is we've done in the previous example. Let me drop it. Okay? Because many of you didn't print it out, so I will try to improve my teaching. If you don't like it print out, maybe I can do it for you. Okay? And you print out the handouts just like Toniolo. You can print the very thick. I don't know whether you take the fluids from it. I think that would be a good one. That would be a good one. But for me, I make the change of the contents quite frequently. So I don't know. because different people with different style, right? Okay, and this one corresponding is to show you how to use a MATLAB and command. So here in both is the MATLAB command. So here in series combination, you simply put the series, and numerical one, data one, I don't know whether you remember that one. Let me show this step here. So for example, for the first case, let me put the numerical case and say s plus 1, s squared plus 1 plus 2. Okay, and then this is s plus 2 plus 3. C, and this is R. Okay. So for this case, this is defined as our 1. So basically here in MATLAB command, you simply, for this one, this is our G1. You put a new 1 equal to, this is all one word, okay, MUN1, no space, no space. And this is numerator, and you put the coefficient in decreasing orders, 1, 1. You put a semicolon to suppress the display in the next line. Otherwise, if you wouldn't put a semicolon, then once you hit the return, then MATLAB will display whatever input you give. Okay. So DEN1, so denominator of this one, basically you put the coefficients 1. Okay, then coefficients for the second, for the S term is 0. And then coefficient for constant is 2. So that is this one. Okay. And then for the numerators, 2, and that one simply equal to 1. And for DEN2, that one equal to 1, 3. Okay, once you have those data ready, then you simply take up this command. Then the output will be given to you. Let me do the calculation. This one will be equivalent. This is my scratch, C-R-A-T-C-H. So for that one will be equivalent to is S plus 1 and S 1 plus 0 plus 2, 1 plus 3. 3 plus 3S plus 2S plus 6. So therefore, your output, once you hit that this command, then if you take away the semicolon, okay, once you hit this command and take away the semicolon, then right away, once you take the return, then MATLAB will give you the answers. AUM will be equal to 1, 1, and they will have a space here. And also DEN will be equal to 1, 3, 2, 6. That is the answer MATLAB being calculated for you. Okay? So in a similar way, that in parallel is simply for this one. I can tell you I barely use this because I can do it by hand very quickly. I don't need this. And the major reason is MATLAB has been keep improving version from versions. So they accumulate or develop a lot of the commands, this kind of things. Okay, I barely cannot memorize everything. So many times when I want to do something, I type help, and the time I spent, or many other people spent the time in looking for help, looking for an appropriate command. That should be easier for user to simply write on their own functions. That'd be easier. So anyhow, that provide to you. This is a little bit particular. This could be useful for you to do the homework, to benchmark your calculations. And using feedback, okay, you can give a try. So basically, this is G1 described by this, and G2 described by this. Okay, and this one could be a little bit useful. And so today we stop here, and we still have quite a few.